Welcome to the Battery Testing Mentor podcast, a podcast about battery testing, battery validation, battery safety, and also battery regulation. My name is Johannes, and we go through these topics together here at this podcast. If you have any wishes, any comments, or want to get in contact with our guest today, just feel free to reach out to me via the typical channels of LinkedIn, YouTube, and so on, or via answering the email. I still send out the summary of the episodes. With that, I don't want to spend more time with the general introduction. Let's just continue with the interview with Phelan about the batteries that High Performance Battery is developing. Now, if you go to such a battery manufacturer and sell him your electrolyte, basically, it needs to work together with all the other components inside the cell, right? And this is very likely very specific to these battery manufacturers, because everybody has his secret recipe and his combinations and so on, his additives that he puts in. Do you need to validate? Do you need to, try it out then every time you start discussing with a new customer? Or is it so generally validated that it will work with all these major chemistries, and then it's really just a little bit of fine-tuning?
Yeah, so I think it's a combination. I think within this market as well, it's never just as straightforward as a traditional sales call conversation. The roadmap and the pipeline length is often very, very long, because especially when you're looking at production, these are not overnight situations that are there. So we have a combination of both, where we are speaking with various different partners that are out there that have existing technology or are looking to be able to step into the market themselves. So our approach is that there should be very little amendments to their existing process that we have mapped out, but there will be on occasions certain differences that are there, and this is where we would go through our due diligence, both from a commercial but also from a technical perspective, that they would also be able to work with us to be able to carry out their own tests, so to say, before that partnership is put in place. We also work with FEV, that enables us to not just be able to provide our internal test results, but also have that third-party testing that's in place that they can use. So in simplification, we try to keep it as straightforward as possible, but there are certain times where there needs to be slight deeper conversation, should we say.
Yeah. Now, if you look back to the beginning of your development, how did you do the testing there in the when you basically do not have the battery manufacturers who give you the cells? Also, did you test the material alone? Did you put it into some cells? Did you take existing cells and kind of disassemble them and replace the electrolyte? I mean, sounds like impossible, but what is the approach that you use there?
So that's a good question, and I think we mentioned right at the start of the call, I'm not within the development team, so this was also probably a little bit before my time. But in terms of how we validate the performance of the development, so not just right from the very beginning, but in terms of how we validate the performance of our development. So we're basically looking to be able to validate the performance of the development by ensuring that we have the reproducibility, so to say, so that our cells can be tested in several, I would say, critical areas. So this really looks at the lifetime of the cells, the behavior of the internal resistance over the time, and their voltage profile during operation. So we really focus on those areas, and by consistently meeting these performance metrics across all of the different multiple test cells, we can demonstrate the battery technology and how it can deliver on the promises of what I've mentioned before of longevity, efficiency, and stability right across a wide range of operating conditions.
Yeah. Okay. And probably you are testing there, like from small cells to bigger cells to these. I don't know if you also address these very large cells that are now, like, especially in stationary energy systems included.
Yeah.
You probably try out everything that is there to make sure it really works all the time, right?
Yeah, absolutely. And I think that's the key for us, is that we focus on the technology development that's there, so our testing, and when we're talking about testing from lab level and then going on to normal size cells or larger cells, and how do we approach that? So it can, present some unique challenges, I would say, taking it from lab level to production size cells. So we have prismatic cells. So we originally started with our smaller test lab cells, so to say, that we then, as you mentioned, completely continuously test to be able to bring that up to production size and prismatic cells that we use. So there's certain properties, I would say, such as the chemical stability and the thermal behavior of our solid state electrolyte, that generally within that testing remains largely unchanged during this transition. So scaling obviously introduces additional complexities in terms of reproducibility and manufacturing processes. And so, for instance, the discharge capacity versus the temperature behavior observed in lab cells from our side of things will closely resemble that of our larger cells. But to ensure that the technology performs consistently in production environments, we do, as you mentioned, carry out extensive retesting of the scaled up cells, and we will continue to be able to do that. So we do that both internally and externally with validations. I mentioned third-party testers that we have in place. And these then for us are essential, should we say, for the certification and the detailed documentation in the industry applications.
So basically you try to validate there really all the behaviors of the battery. I guess not only the performance, but also the safety, also the, as you said, different behaviors at different temperatures to see if there is some impact. Is there some like specific focus that you go into and say, okay, we are called high performance battery, so performance is number one, and we need to kind of really make sure our battery has the performance that our customers want? Is it such a kind of very focused approach?
Yeah, that's just a great question. Yes, it is. So we have, I would say, our validation process. We have our focuses. I think most companies will have their focus, so to say. But from our side of things, we have several key areas that ensure that our battery meets all of the required standards. So we have lifetime testing, we have thermal testing, we have safety testing, and we have, as you mentioned, performance testing that's there. So from the lifetime testing, we're looking to be able to verify how long the battery can operate effectively under realistic demanding conditions. So this is including frequent charge and discharge cycles. So that's one of, I would say, the four arms of our validation process. We have thermal testing, where we test the battery's performance across a wide temperature range to make sure that it remains stable. So I mentioned before that we have quite a wide temperature range that's in place from minus 40 degrees to plus 60 degrees, which is, also for us when we're looking at our application areas, that minus 40 to plus 60 is an extremely wide range, and that's one of our key USPs, so to say, that we have that. I think for everybody as well, safety testing. So safety is absolutely paramount, and we're rigorously testing the battery for resistance to overcharging, thermal runaway, and mechanical stress. And then the last one, as you rightfully said, actually you mentioned it last, but it's right at the very beginning as well, is the performance. So looking at the evaluation of the battery's capacity, so what its power output, and generally its overall efficiency to make sure that it's delivering the expected performance for this application. So again, as I mentioned, I can't go into too much detail in terms of how that is broken down, but what I can say is from our development team is that all of these steps are the key areas, the key tranches of focus, and they're all carefully sequenced with safety and reliability, obviously, and performance taking that priority that's there as well.
Yeah. Do you know if like this is then all kind of mixed in each other and tested at the same time? Or is there really something like, okay, we have now our like first prototype and we just go into performance and then see if we should go ahead? Do you have insights into this?
Don't quote me on this because
I won't. It's just
don't quote me on this. But
online.
when we have those 4 tranches that's there, we have a look at those 4 areas that's there. I think there's always an element of an initial focus on one specific that it has a higher percentage of focus that's there, but they're all worked in sequence. It's not that we just look at one and then move on to the next one that's there. There is a higher focus on one specific area, but in the background that we still have the tests that are carried out, the analysis that's carried out on all of these different tranches that take place.
Yeah, interesting. And then, I mean, this is now the timeline for the development, basically. The big question is then, how do you make sure that after the development, it's also working in the gigafactory somewhere, different country, right? Different operators. They are not your employees. They are the employees of some battery manufacturer. How do you make sure it really works reliably even then?
Yeah, also another good question. So I think this is the key answer to this is how we are working with our testing and with our innovation that's within the lab. So what we're looking to be able to do is make sure that we're aligning as much as possible the lab scale production and gigascale manufacturing by designing our test cells and using a process that's as close as possible near series production process. So this means that our lab test cells are produced in a way that mimics industrial production methods. So we try and keep that as close as possible. Obviously, there's variations that take place, as you mentioned, in different regions, different areas, but throughout all of our testing, we are looking to be able to keep our test cells and our build of our test cells as close as possible using near series production. So they're produced in a way that mimic the industrial production methods. So that allows us to be able to ensure the scalability of the technology. It allows us to be able to look at controlling and keeping a tight control over the material properties, the production parameters, and the cell assembly techniques. So basically what we're trying to be able to do is minimize the variations and ensuring that reproducibility when transitioning to a large scale production is in place. So from our side of things, this approach really looks to be able to reduce the risk of discrepancies between the lab and the factory, the outcomes, and also it builds that confidence on the scalability of our battery.
Yeah. I guess you're also giving very specific requirements to the customer then how to implement your component, the electrolyte, in the production process, right?
Absolutely, and that's something that really then falls into the package, I would say, of our licensing model that's there. So that's when we're looking to be able to have that partnership in place. It really is a partnership that's there, that we have the technology, and we have the processes, and we have our background that's there, that is shared and worked in partnership to allow our distribution, but our production partners really to be able to make the most of that technology and take it out to the best of their ability.
Okay. What would you say is really the most important things to test and validate? I mean, also in terms of when you talk to customers,
Yeah.
what are they normally asking for? Is it really the performance, or are they more concerned about, I don't know, safety, or just is it something completely different that has not even something to do with the battery itself or with the component itself?
Yeah, so from a customer's point of view, obviously one of the big things that's out there. I mean, we have various different customers and various different applications. Like I mentioned before, we focus on stationary storage, but that stationary storage can be applicable in lots of various different application fields that's there. So one of the common themes, and from my side of things, I think it'd be interesting when we look back, in 5 or 10 years, that the issue of safety is always a key element that's there in solid state batteries, and especially from our side of things, looking at that non-flammability. I think it would be crazy to be able to think in 5 or 10 years when we look back and say, okay, from whether it's data centers or whether it's home storage, that there were actually, and even on vessels, maritime vessels, that there was a technology, a battery storage technology that was there that was flammable. So from our side of things, obviously that's what's really interesting in terms of our clients and what it is that they're looking at. The lifetime, so the longevity as well, is also something that's really interesting, really key from our side of things. We have a full SOC from 0 to 100%, but we also have a long cycle life that's there as well. So that's on the customer side, and that, those are probably the key areas. We get lots of different questions in terms of technology requirements and performance metrics from various different partners that are out there. But I think also from our side of things, we also need to be able to anchor a little bit in terms of what's important for us to be able to deliver that, and what's important for us to be able to test and validate, to be able to support these range of customer requirements, so to say. But from our side of things, especially on production, one of the most critical aspects to test and validate in our development anyway is the scalability, and we mentioned reproducibility before. So the scalability, should we say, is ensuring that the technology can be relied on, so that it can be efficiently produced at industry volumes. We've had, if you look in the news at the moment, you see that some of the biggest challenges that's out there is making sure that it is able to produce to industry volumes, but without compromising any performance or quality that's there. So for us, the first one is the scalability. The second part then is reproducibility. So it's looking to be able to make sure that every battery that is looking to deliver consistent results, which is then essential for the applications requiring that high reliability, such as the energy storage that you've mentioned before. So this also applies to our electrolyte as a single component. We mentioned before, not just on the stationary side of things, but also as a single component for the electrical vehicles, the EV market, making sure that reproducibility is in place. So these are the two key factors that are central to our development process, I would say, as they're really determining how successful the technology can be adapted into the real world.
Very, very fascinating. It's really a big thing, I would say. Like, even though it's only kind of an electrolyte, it's still like a huge, list of requirements that fall into this, right? To develop it and to make sure it really works well.
Yeah.
And maybe if you look at this kind of all these requirements and everything that is coming on and coming there and coming onto you, what is like a typical timeline? Like, how long did it take you to develop this electrolyte from kind of early idea to really the point where you say you are now in talking to customers about licensing it and using it in their production?
Yeah. So, another really good question. I think I mentioned right at the beginning of the podcast as well that our technology has been based on over 30 years worth of that research, of asking those questions about aging. So you can almost look at it as in two parts. So there was a lot of research that was done in the early stages, looking at not necessarily solid state batteries and that technology, but answering those questions of aging. Do batteries need to be able to change, as I mentioned before? So there's been a lot of work and effort and research and innovation that's taken place, over the last 30 years. But I would say then, really from that penicillin moment, when there was that, okay, solid state batteries, this is our technology, this is how we're approaching it, being able to take it forward. That really began in 2018. But we've also mentioned as well, the innovation's a continuous journey. So we are now at a production ready stage. So there's been that huge amount of work and effort that's gone in the background, that we're now at a production ready stage. But obviously, our development efforts are continuing to to be able to refine. The market is changing. The focus of requirements is often changing. So from our side of things, this is why our business approach is to be able to remain as that technology developer, that we can really focus on making sure that we are driving that innovation, we are enhancing that technology, to be able to make sure that we're at the forefront. But long answer to the short question, there's been a lot of work that's gone in the background. We're now at serial production stage ready, that we would look to be able to get that technology out into the market. But the last part of it is that it will just continue to innovate.
Yeah, that's a good outlook in the future.
Yeah, absolutely. Absolutely. It's exciting times.
Yeah, it was really interesting to talk to you. Do you have anything else that you wanted to address that we missed out so far?
I don't think so, actually. I think that was I had an excellent interviewer for the podcast. So I think going through the questions in terms of both our approach to the market, where we've come from, and also our next steps, has really covered everything. Just like to be able to say thank you very much for the time. It's always great. You can probably hear from my voice how enthusiastic I am about the technology that's out there. So it's, I could probably talk forever, but really, really good to be able to speak with you, Johannes.
Yeah, it was super interesting. Thank you for your time. And I'm sure we can meet again at one point in time and then see kind of your electrolyte really in large scale production.
Absolutely. Look forward to it. Thanks, Johannes.
Yeah, thank you. That was the second part of the interview with Liam Phelan. I was very glad to have him here at the Battery Testing Mentor podcast. I hope you also could take some learnings with you. If you have any comments, reach out to me. And otherwise, I wish you a happy 2 weeks ahead, and see you next time here at the Battery Testing Mentor podcast.